today we're continuing with functions and relationships, okay? So we're going to be doing equivalent forms of representation. So we can represent relationships in different forms. Okay, so today we're going to be exploring. Yay! So Noah's going to answer everything for us because they did this in class today. Okay, so today we're going to be doing multiple forms. We're going to be matching one form with a different form so that we're able to recognize the different ways to do all of these. Okay, not really. I promise you, you can do it. All right. Okay, let's check what's happening here. So I have 4 equations on the screen right now and 4 tables. So we're going to start off our lesson by matching the equation with the table. Now I'm going to tell you the best way to do this is to substitute. Okay, we see here, we spoke about it. X's always represents the input. What are you plugging into your equation? And then obviously your Y will represent the output. So you can look here, there's our Y, there's our X. X's, X's, and X's. And then Y's are in blue. So we're going to plug in X's and see if it gives us the same answer as the Y. And that will therefore mean the equation and the tables match. Now let's try the first one. Okay. The screen is blank again. Okay. That was terrible. I shouldn't sing when I'm sick. Oh my goodness. Okay. I hope everyone who couldn't see can see now. So I'm going to make an example with 1.1. It says y is equal to 2x plus 4. So I'm going to write y equals 2x plus 4. Let's try it with table 1. So if you substitute an x of -3 plus 4. What's 2 times -3, beautiful people? You're welcome, guys. What's 2 times -3? -6, -6, oh, -6, thank you, Paul. And if you add 4, that'll give you an output of -2. Is -2 the output we are looking for when we substitute -3 for table 1? I know, singing is a problem. No, it's not the output we're looking for. So already we know that 1.1 is not the table we're looking for 1.1. Table A is not the table, right? So no, we know it's not table A. Let's move on. Let's try it with table B. This time I'm going to substitute 2 times an input of 2 plus 4. What is 2 times 2 plus 4, beautiful people? 2 times 2 plus 4 is going to give us how much? That is correct. So this is going to give us 8. So now we are on table B. When you have an input of 2, is 8 the output you're looking for? For table B, is 8 the output you're looking for? No, it isn't. Look carefully for table B. We inputted 2, which is over here. Let me highlight it for us. We need to keep track about where we're working. We inputted 2, so we wanted an output of 6, but in this case, we got an output of 8. However, there is a table on the screen that corresponds with an input of 2 and an output of 8. Who can tell us which table that is? Input of 2, output of 8. No, it cannot be table A, guys. In table A, when you input 2, you get an output of 3. Yes, it's table D. It's table D. Let's look at table D. When you input 2, you get an output of 8. Let's try it with a different input. 2 times 4 plus 4. And this gives you 4, 8, 9, 10, 11, 12. So indeed, table D matches up with 1.1. 1. So do you see how you're supposed to do these, guys? Whoever was saying this is difficult, they did it at school. Can't you see table D? Should I scroll down a little bit? There we go. Can you see it? Okay, so this is how you expected to do this. Okay, you substitute and then you see whether it matches. So we have matched number 1.1. Now let's try number 1.2. Number 1.2 is a little bit more complicated, right? Our y's and our x's are on both sides, which I don't necessarily like. All right. If you want to keep it that way, that's fine. Let's just substitute. You're welcome. Say table D is taken. This is number 1.1. Let's try table A for number 1.2. Okay, so 1.2 says 2 times x plus 3 times y is equal to 6. Now let's substitute an input of 1. Okay, so 2 times 1 plus 3y is equal to 6. We have learned how to solve for y. Who's going to tell me how am I going to solve for y? If I have 2 plus 3y equals 6, can I have someone who's going to solve for y for me? With me? Anyone? There we go. Yes, Paul.
Hi, ma'am.
Hello.
So 3y is equals to 6 minus 2.
There we go, which is 4. Therefore, y is how much?
4 divided by 3. Still like 4 over 3. No.
Yes. So when we substitute 1, do we want an output of 4 over 3 for table B?
Weird.
Look at table B. Yes.
Yes, ma'am.
So we substituted 1, right?
Yes, ma'am.
What is the output we were looking for?
We were looking for 12.
Wow. So that means 1.2 does not match with table B. Do you see that?
Yeah. Yes, ma'am.
Thank you. Paul, do you want to do one more substitution with me?
Yes, ma'am.
Beautiful. Now let's try table C. Which input do you want to choose in table C so we can test it?
-3.
-3. Let's do that. So 2 times -3 plus 3y equals 6. Go ahead. What do I do now?
You multiply first 2 times -3, which is actually -6, plus 3y, which is equal to 6.
Okay, and
then you transpose to 3y, which is 6 plus 6, which is actually 12.
3y is 12. And then my final answer
is 4.
Is that the output we wanted?
Yeah.
Yes.
Table
So
C.
1.2 matches with table
C.
C. Thank you for helping me find that. 1.2 is table C. Beautiful. Oh, that's beautiful. Okay. Now let's see. We have matched table 1.2 and 1.2. Now we need to match equation 1.3. Has anyone matched it? Does anyone want to substitute with me so we can match table A and B as well as 1.3 and 1.4? Let's hear. We are substituting some yellow to match the equations and the tables. Okay. That's what we're doing. So let me do, we've already matched equation 1.1 and 1.2. Now let me do this so that I don't confuse you guys. Let me wrap this out. Now we are on 1.3. The equation for 1.3 says xy is equal to 12. So you have to substitute x, see if you get the correct y, and then match the table. Okay. So table A and B are the only ones that are left. I'm going to try table A. So if I input x, 1 times y equals 12. Therefore, y equals 12. So for an input of 1, I did indeed get a output of 12. That was very easy. That means 1.2 3 goes with table B. You see what I did, guys? We were substituting. Table B. Yes, can you see I got it? And Amahle. And then the last one, guys, it's always a good idea to check your answers, okay, in case you made a mistake. Let's see if 1.4 matches with the last table. X squared minus 1. I'm going to choose an input of -3. -3 squared minus 1 equals -3 times -3 is +9. Okay, let me erase this here. Let's go confuse us. It's +9 minus 1, which is 8, and that is indeed the output we want for table A. Because when you input -3, you get 8. So therefore, 1.4 corresponds with table A. Are we with me? Please explain C again. No problemo. Okay, here's C. XY equals 12. That means X times Y equals 12. So I chose to test an input of 1. So input is always the X, right? So wherever I see X, which was there next to the Y, I just plugged in a 1. So 1 times Y is just Y equals 12. And 12 is indeed the output we were looking for if we plugged in 1. Do you see that? Person who asked for explanation, do you see that? Dalo? Yes, I hope so. Someone say, please explain D. Okay, D was table 1.1. So 1.1 said Y is equal to 2x plus 4, and we put it down there. And then we chose an input of 2. So wherever you see an X, which was there, we plugged in 2, and our answer was then 8, because 2x means 2 times 2, right? Which is 4 plus 4 equals 8, and 8 is indeed the output we were looking for, which is why we matched the table. Listen carefully, guys. I just explained C. I'm going to explain it again. Okay. We are just substituting, guys. We're just substituting. 2x plus 3y equals 6. Wherever you see an x, put your input, okay, which was there. I chose an input of -3, and it gave us an output, if you work this out, of 4, okay? Because 2x means 2 times x, 2 times -3 is -6, plus 3y equals 6. We transposed the -6, as Apostle nicely told us, and it went over and became a positive. If you look at -6, there it's a negative. If you take it over, it's going to be 6 plus 6. That's where we get that 12. Okay? And then to get rid of the 3 in front of the y, we divide by 3, divide by 3. That's why our final answer is y equals 4. And that corresponds with the output we wanted. Okay. If you still struggle with substitution, we did do a lot of substitution in algebraic expressions and equations. All right, so that was the first type of mixed masala representations. The point is you need to be able to identify which table goes with which equation. I forgot to write for 1.4 that it goes with table A. So 1.4 goes with table A. Okay, I hope we're all good. Let's see. So now we're going back to flowcharts, all right? Flowcharts. We're going to choose 1, 2, 3, 4, 5 inputs. We're going to apply the equations that we've written here. And then we're going to write them outputs. Okay, so give me some inputs that you would like to use in this case. Give me some negative and some positive. Let's hear. Sia says 4, Gamkhana says 5, -5. Okay, I'm going to go with -5. Ooh, -7. And there was a 4 somewhere. -9. Let's go positive now. 8. 3/5. Ooh, time to spicing things up. 3/5. And we need None. We're done. So we have chosen the inputs of -7, -5, 3/5, 4, and 8. Tell me in this block, first block over here, what should I write? Remember, we have to express this equation as a way of flowchart. Okay, so you must tell me in these blocks, you first do this and then you do this. Yes, okay, almost. Remember, we never write the X's and Y's inside the blocks. You just write the operation that you do in the block. Yes, Paul. So we say we're first gonna multiply by 2,5 because we already have all our X's on the left. Do we see that? Our X is already there on the left. So we don't have to rewrite X because the X's are here. We have chosen X's to be. I should actually move this up and write down what our X's are. Let's see if I can this. Yes. No, not output. What's in the next block? What's in the second block? So we've established that the first block yes, Kamachelo. So here is our X's, and that side's going to be our Y's. So first multiply by 2,5, and then you plus 1,5. Beautiful. Now let's do that. What's -7 times 2,5? And this is where we need our calculators that I am so unprepared for, but I have found some sort of calculator. We're fine. What's -7 times 2,5? Sorry if my voice is it is the sickness, it is not the me. What is negative? Thank you. And then we have to add 1,5. So what's our final output? -16. Thank you, Karabo. -16. So for -5, what is our output? For -5, yes, Karabo, -11. 3/5. What is our output there? That is indeed correct. For 3/5, our output is 2. Guys, we really chose nice inputs because we seem to be getting whole numbers. Let's see if that lasts. For an input of 4, what is our output going to be? Yeah, I spoke too soon. That is the end of our whole numbers. What is our output if our input is 4? That is correct, guys. 11,5. And then if our input is 8, what is our output? Thank you very much. Who is it? Lomso? That would be correct. The last one is 21,5. Okay, so now we're going to just fill in our information on our tables. Tell me on the column that says X, which numbers do I fill in? We have a column here, a row. We have a row that says X. Which numbers do I fill in? The ones on the left or the ones on the right? Okay, I see a lot of people say right. Okay, 2 people said left, another one said right, left. Remember, you have to ask yourself, what is X? Is X our input or our output, guys? X is our input. Okay, so if X is our input, that means we have to fill in the numbers that are on the left. See, it says it there. X, this is our input. Do we see? And that means in the row that says Y, we have to fill in output. Okay, so then let's fill them in. So in X, I'm going to fill in -7, -5, 3/5, 4, and 8. And then that means for our output, I have to fill in -16, -11, 3, 11,5, and 21,5. Okay, someone said, please re-explain 3 over 5. Let's do it on the side here. 3 over 5, we have to first multiply by 2, 5, and then add 1, 5. So if we're going to turn this into fractions to make it easier, you're going to have 3 over 5 multiplied by 2.5 plus 1.5. Okay, this is for people who don't like calculators like me. 2, 4, 5 over 2 plus 2, 3 over 2. These 5s can cross cancel, so you're going to be left with 3 over 2 plus 3 over 2, which is 6 over 2, and 6 divided by 2 is 3. I hope the person who asked has gotten their answer. Oratile, let's hear what you have to say.
Hi, ma'am.
Hello.
Ma'am, mustn't you turn your fraction into a decimal, ma'am, or does it give you the same answer?
It's the same answer, it doesn't matter.
Okay, thank you, ma'am.
It's a pleasure. That was a beautiful question. Okay, guys, so if you look here carefully, you have represented one relationship as an equation, an expression, excuse me there, 2, 5x plus 5. You've represented it as a flow diagram, and you've represented it as a table. I saw someone ask, when are we doing graphs? In the next lesson, we'll be doing graphs. Okay, we'll be starting graphs today, but for now, we were focusing on, we have to perfect these types, because after this, all we will be doing is turning these into graphs. So there are 4 forms of representation. That is an expression or equation, a flow diagram, a table, and a graph. So you guys did all 3 in one go. How do we feel about that? How do we feel about that? To us who don't like calculators, like me. Okay. Now we're going another direction. We are given tables and we want to express these as equations. Okay. We want to express these tables as equations. Obviously, we want the relationship between the input and output. How are we going to do this, guys? Who has an idea? Oh, that sounds terrible. Absolutely horrific. Let me do this. There we go. How are we going to do this? We already did this. Come on, go look at the videos. CSS gradient. We haven't done that yet. Anyone else have another idea of how we're going to do this? Input times output. No, remember you have to times your input by something else to get to your output. So what would you times your input by to get to your output? Oh, we have forgotten our number patterns. Do we remember number patterns? What would you do if this were number patterns? Let's hear what people have to say. Oh, Mpa's figured it out. 2x minus 1. Let's see, 2x. Okay, it works for the first one. But after that, not so much. Oyama says negative 2x minus 1. Yes, you would find the rule, Tepang. So what would you do? First thing you would do is you would check the differences between the outputs. So from negative 5 to negative 1, what did you do? What did you do, guys? It's okay, Tobile. Please watch this video. We're going to upload it on the website, okay? Thank you, Paul. We are adding 4. Do you see that we keep adding 4? What did we do with that 4? Does anybody remember what we had to do with that 4? Now that we've established that we keep adding 4, we have to use this 4 to do something. What did we do with that 4? Yes, Amahle, that's our constant difference. So what are we going to do with it? We made it our multiplier. Do you remember that? So we would say 4 times your input, x. Then you have to tell me, what are we going to do between 4 times x in order to get to our y. Do you remember this, guys? Do you remember this? You have to tell me what we do between 4 times x to get to our y. Remember, no personal information in the chat, please, at all. Because if you test it, let's say we test it with an input of 1. So it's going to be 4 times 1, which is 4. Is 4 the output we're looking for when we input 1? Check there. Is 4 the output that we want when we input 1? Are we looking at our table? No, Paul, what are we supposed to do to 4 to get to 7? Thank you. Tepang remembers. Plus 3, because we can add 3 and we get to 7. Now you have to test it with the other inputs. If you say 4 times negative 1, it's going to give you negative 4. If you add 3, that gives you negative 1. When you input negative 1, yes, when you input negative 1, do you want an output of negative 1 as well? Let me highlight it so we can see it nicely. When you input negative 1, do we want an output of negative 1? Yes, guys, we've established that we had to add 3. Yes, so that means our formula does what? It works. It works, guys. Do we remember this? I hope this is coming back to us because we did quite a few of these. I did it with you. Okay? If this is vaguely familiar, please go remind yourselves for the exams and watch those videos. That means our final formula is then y equals 4x plus 3. And I got that with the help of you lovely people. My boss is terrible. Let's never draw again. Woo! Now that I've refreshed our memories, let us do the second table. Okay? Step 1 was what? What did I do first? What was step 1? Oh, your exam was on Monday. Oh, yes, let's September. We have to find the rule, but what was the first step? Divide. Now's the time. I'm explaining again, okay? What was the first step of finding the rule, guys? Thank you, the difference. Okay, so how do I get from 6 to 1? How did I get from 6 to 1? Thank you, Paul. We subtracted 5. How do I get from 1 to negative 4? I subtracted 5. So we have our constant difference, which is negative 5. So from the viewer who said, please explain. Once you find this difference, okay, you're going to make it your multiplier. I'm going to explain now what that is for people who went in the class when we did this. Okay, that means you're going to say negative 5, excuse me, and I'm going to times it by your input. Okay, then you have to figure out what do I have to add or subtract. See where I'm highlighting blue, to get the output that I want. And the only way to determine that is to substitute. Okay, I'm going to substitute into negative 1. I'm going to substitute into negative 1. Tell me, guys, if I substitute negative 1, what is the output I am looking for? If I am inputting negative 1, what is the output I'm looking for? Look at the table. It is positive 1. Okay, see my x is negative 1 and y is positive 1. So let's see how we're going to get there. So if I say negative 5 times negative 1, how much is that going to give me? How much is negative 5 times negative 1 going to give me? You just choose, Leti Temba. I'll tell you just no. You're going to get a positive 5. Is positive 5 what we want? No, you just told me we want 1. So what am I going to do to positive 5 to get to 1? I have to subtract 4. And that's going to give me 1. Now let's check with a different input. I think I forgot who asked me now, how do you know what to substitute? You choose what to substitute, and then you look at the corresponding outputs. Of course, a helicopter is going to fly during our lesson. Yo, guys. Yee. But anyway, it's gone now. So if I choose to substitute, let's say 2, I want an output of negative 14. So let's do so. So you're going to say negative 5 times 2 minus 4, because you guys told me I must subtract 4. What's negative 5 times 2? What's negative 5 times 2? Thank you, Paul. Negative 10. And if you subtract 4, you get negative 14. Is negative 14 the output we are looking for? Look in the table. Yes. So do we see how this works, guys? Therefore, my final equation will then be y is equal to negative 5x minus 4. Okay, I hope this is making sense. All right, how are we feeling about this? Let me have a check-in point. Thumbs up, thumbs down. Beautiful, Letty Tenda, that's what we want. Okay, I see thumbs up in the reactions. I'm waiting to see if I see a thumbs down so that I can explain. If you're gonna say thumbs down, please raise your hand and tell me exactly where I lost you so we can find you quick. Canva is scrumptious. Okay, looks like we're all doing well. Looks like we are good. Okay, we'll have a brain break just now. We still have time. We're gonna do one last one. This time, Oyama, you need to raise your hand, my dear. Tell me where I lost you. Oh, I forgot to fill this in. This was minus 4. Raise your hand, Oyama. So we can help you here. There we go. Hi, Oyama.
Hello, Miss.
Where did I lose you? You must go back up.
You lost me by the first part because what you call this, my mom called me. Then I didn't see how you explained.
Okay. So all I did was I found the constant difference. Do you see here? To go from negative 5 to negative 1, we add 4, add 4, add 4, add 4. You see that?
Yes.
So we're going to take that 4 that we keep adding, multiply it by your input. So 4 times 8. Okay?
Yes.
So if you say 4 times x, you want to know what else do you have to do to get to y. So we tried it with an input of 1. So I said 4 times 1, and that gave me 4. But when you input 1, you do not want an output of 4. You want an output of 7. So that's how we decided that you have to add 3. You see that?
Yes.
And then we just tested it with a different input. This time we said 4 times negative 1. Add 3. You check. If I have an input of negative 1, do I want an output of negative 1? Yes, indeed we do. That means our rule is correct. So you write it down. Okay.
Yes, understand.
There we go. Okay, guys, we have one more to do before our brain break. Still have time. In this case, we will be substituting. But if you look carefully here, they told us which inputs we should use. So this time we're not choosing for ourselves. We have been told we need to use the inputs of x equals 5, x equals 0, x equals 34, x equals 1, x equals 6, and x equals 20. So tell me, those x equals that they gave me, where do I fill them in? Where do I fill those numbers in? Negative 5, 0, 3 over 4. Where do I fill those in? on top. Thank you, Lugue. So you're going to fill in there where it says x. You're going to see -5, 0, 3/4, 1, 6, and 20. Okay, then so nicely for us, they have given us the formula of how to find your outputs. So we're going to substitute all of these inputs that we got to get our outputs. Okay, so then we're going to fill in our outputs there where you have y. So let's get going. Okay, for y, for x equals -5, what's my y going to be? Because you're going to say y equals -4 times -5 plus 3, which is equals how much? 23. Beautiful. Because this is 20 plus 3, which is 23. See, guys, if you don't need a calculator, don't use it. Okay? People who've been with me long enough know I'm allergic to calculators. It's just that, you know, today I took allergics so that you guys can at least use calculators a little bit. But if you don't need them, don't use them. Okay. 23. Next input, 0. What's my output? Next input is 0. So we have y equals -4 times 0 plus 3, which is how much? 3. It's going to be 0 plus 3, which is 3. Beautiful. Next one, 3/4. Y equals -4 times 3/4 plus 3 equals, let's see, 6. That is correct. Is it 6? No, it's not. It's not, because this 4 and this 4 will cancel out. So you're left with -3 plus 3, which is 0. So for 3/4, answer 0. Next input, y equals -4 times 1 plus 3. What's my output? -1, because this is -4 plus 3, which is -1. Next input, x equals 6. What's my output? Oh, I know someone is probably thinking, what is going on with these people? -4. You guys are on fire today. Plus 3 is how much? -21 is correct, because this is -24 plus 3, which is indeed -21. My last one is x equals 20. What's my output? Let's see. -77. I wouldn't know. I haven't checked. So -4 times 20 plus 3. Yes. So this is going to be -80 plus 3, which is -77. Beautiful, guys. This was -21. Let me fill it in quickly. -77. Now, we have our x's and y's, okay? Okay, we have our x's and y's. So now, this is where we are going to introduce graphs, okay? Before we do anything about graphs, we need to understand coordinates. All right, so once you have your input and your output, the way we write coordinates is open brackets, your x point, so -5, semicolon, your y point, which is 23, close your brackets. So I need you guys to tell me, what are my next coordinates? What are my next coordinates? These represent something extremely important, so we need to learn how to write them absolutely correctly. Okay, Mpo has our next coordinates. Mpo has our next coordinates for us. No, Sia, I will not take it until you write it exactly the way I want it. I want my brackets, the x coordinates, semicolon, y coordinates, and close brackets. Guys, let's get back to the lesson. Back to the lesson. Okay, so our next ones are 0, semicolon, 3, close brackets. Beautiful. Next ones, 3/4, semicolon, 0, close brackets. Next one. Yes, guys, we're getting this. We used our x's and y's, okay? Can you see here, it tells us that in your coordinates, the x is first and the y is next. Let's see, y. So they are separated by a semicolon, and you always write them in brackets. I will not accept them if you use a comma. I will not accept them if there are no brackets. So the next ones, you have your x, which is 1, a semicolon, your y, which is -1, close brackets. Beautiful. What's my next ones? Yep, we've skipped one, but thank you, Sia. Olorato, no, I'm not accepting those. Okay, these ones are 20, semicolon, -77, close brackets. There we go. 6, semicolon, -21. I should have had more space for myself, but it is what it is. Yes, or no, Oratile vanished. I thought Oratile had a question. Okay, so guys, you better write these correctly, okay? You will lose marks if you don't write my coordinates correctly, not just for me, but at school as well. So always, x, semicolon, y, both in brackets. Great, that's our introduction to graphs. Let's have a quick brain break. We have a maze. We have a maze. This is how it's gonna work. You're gonna substitute the x and the y. Okay, so there where it says x is equal to 6, you substitute it there. If y is equal to 1, you substitute it there, and you find your answer. Now, your answer, you're going to check in the key above here. And ice cream is 1. So if your answer is 1, it means you're moving that way. If your answer is 2, which is 2 ice creams, it means you're moving that way. If you take your answer and you subtract to no, I don't know what that means. Subtract 2 ice creams, then it must lead you that way. But you guys get it. So in my first block, we're starting at block A. What's my answer? X is 6, y is 1 plus 6. What's my answer? So we have 6 minus 1 plus 6. Guys, why are you so devastated? It's such a nice thing. Somehow you didn't tell me the world was ending in the chat. Hi, Bo. Hi, guys. I didn't know that the world was ending. Can't I'm busy explaining if people are like, it's tap out. Hi, guys. Your brain is on fire, which it should be. Welcome to my class. I'm kidding. Okay, what's the answer for A, guys? Just watch carefully, Keegan. What's our answer for A? 11, okay? Because when you plug in 6, oh my goodness, A says x minus y plus 6. So it's going to be 6 minus 1 plus 6, which is equal to 11. So my answer is 11. So 11 is, excuse me, the 2 ones, isn't it? A 1 and a 1, that's 11. So we're going down. We're on block number E now. See, guys, it's not that bad. It's not that bad. What's my answer for that one? Mpo, yes, Mpo.
I want to answer.
Let's hear what you have.
So I did like 10 plus 2 times 4, which is actually equals to 8 minus 15. Then I've already added first. 18 minus 15, which is actually equals to 3.
Okay, let me do this. So it was 10 minus 5. Wasn't it minus 5?
Wait, what?
Plus 2. Look carefully. It was 10 minus plus 1.
Wait a second. So 10 minus 5 is actually 5 plus 2, which is actually equals to 7.
7. So where are we going according to our key? 7 is this blue little thingy here. So where are we going? Are we going across or down?
Down.
down. Thank you. So it's I. See, guys, it's not that bad. You guys are dramatic. You guys are so dramatic. I says 5 minus x is 3 divided by y is what? 1 plus 2. The only trick here is you need to remember board mass, okay? So it's going to be 5 minus 3 plus 2, which is how much? 5 minus 3 is 2 plus 2 is 4. So where we're going? 4 corresponds with what? The watermelon or the flip-flops? The watermelon or the flip-flops? Where we're going? The flops. Thank you very much. So we are going to J. See, guys, it wasn't that bad. You guys are making me sound like such a terrible teacher. I love you guys so much. So we're on J. J says x squared, which is 5 squared, minus 10 plus y, which is 100. So it's going to be 25 minus 10 plus 100. How much is that, guys? How much is 25 plus 10 minus 100? It is helpful, guys. See, your brains are working. Amashe says 115. Okay, where are we going? So a 1 and a 1 are 2 lollipops. 5 is the losses. So we have to go up. See, guys? We have to go up. Because it's the lollipop losses. 1 and a 1 and a 5. All right. So now we are on F. We're on F. Guys, this is helping with substitution, which we've been doing now. Just now. What's the answer for F? Has anyone figured it out? It's going to be 5 times 2 squared minus 2, which is 5 times 4 minus 2, which is 10. So 10, we have 10. Which block are we going to? Are we going to K, to G, or to C? Let's hear. We're going to K. We're going to K. See, guys, you guys are scared. This is why we have exam anxiety. We know these things, but because we see so many numbers and variables, we freak out. And we shouldn't, because we know our work. 3 plus 10, which is 15, minus 13, and that's 2. Where are we going? Tell me which block we're going to. We're on K now. We're on K. We're going to G. Aha, we're not finishing. That's going to be 3 cubed plus 10 divided by 2. So that's 27 plus 5, and that is 32. A 3 is a watermelon, and a 2 is a coconut. So we are going up to C. Woo! We're going to end up doing this whole maze. Okay, let's hear. What's the answer for C? What's the answer for C? 4 times 12 divided by x, which is 8. 4 times 12 is 48 divided by 8 is how much? What's my answer for C? Alright, but guys, the quicker we do this, the better. 6. Thank you. And 6 corresponds with the H. So on block H, guys, we could be done and you guys are giving up. 6 times 2 plus 4 times 3, which is 12 plus 12. And that is 24, which corresponds with this block. And we are finished. Woo, what a beautiful brain break. Woo. What a beautiful brain break. Guys, it was not that deep. You guys are just dramatic. You guys are just dramatic. Okay, let's do, I'm kidding. I'll give you guys, no, but we still have time. So I'm gonna make us do one more thing. One more thing, guys. One more thing. we're going to work backwards. So I'm going to take the coordinates that we have over here, and we're only filling them in the table, guys. We're only filling them in the table. We're not doing anything dramatic. Okay, so I need you to tell me in coordinate number 1, which one is the X? Which one is the input in coordinate number 1? Think of this. Think of the notation for coordinates, okay? X's come first, Y's come after. So in number first coordinate, which one is my X? It was helpful, can you see? Let's see. Which one is my X? Mulebogeng. Mulebogeng, ask is, yes, Mulebogeng. You can unmute Mulebogeng. Guys, look carefully. In our coordinates, which one comes first, the X or the Y? Yes, Mulebogeng, you are unmuted.
Is it important to write brackets?
Yes.
Okay, thank you.
You're welcome. Okay, guys, so we've all established that X comes first. So if X comes first, then in our first coordinate, which one is X? Is it -2 or is it 0? There we go, guys. So then here you're gonna fill in -2. Okay, so for -2, your Y is what? What's my Y? 0. See, guys? So basically just learning how to represent them differently. So for -2, we have a 0. For the next one, let's move my red arrow. For the next one, which one is my X? From the next one, which one is X? -1, and therefore my Y has to be what? Therefore my Y is 1. Beautiful, beautiful. Now on the next one. We're there. Which one's my X? It's 0, and your Y is 2. Okay, we don't have a 5. For the last one, which one is my X? 2, nope, 10, and the Y? 12. So you can fill in these coordinates over here, -2, 0. Nope, that's the wrong column. Sorry, before we freak out. So I have a challenge for you guys. I want you guys to screenshot this and try to find the formula for this table. So I want you guys to go and be like, Y equals something, something, something X. That's where we are starting in our next lesson, okay? And once you have that Y equals blah, 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 fill in the Y for 5 and the Y for -5. Yes, you can screenshot, okay? Oh, why can't you screenshot? You can watch this video again if you want. Do you have a button that says PRTSC? Bye, guys. Yes, it is. No personal information in the chat, okay? If you're on your laptop, press PRTSC. Then you go to any Word document and you just press paste. Okay. Yes, we are. Guys, this is where we are starting in the next lesson. We will be doing this table and drawing the graph.